Okay, so we are going to do some distance and displacement, speed and velocity notes. So on your notebook, you're going to want to go to the next page. So after your CK12 readings that you did, you're going to move on to this distance and displacement, speed and velocity notes. So I'm going to jump over to a PowerPoint in a second. Since it was started on 9/21, I put that as the date, but if you want to put whatever date you're doing it, that's great as well. And don't forget to add it into your table of contents that you made. So go back to that, and I've already done it, distance and displacement, speed and velocity notes, and I started it on page 3. So that is getting all ready for this. Now, I'm only going to jump back to this screen and do the math problems with you in here. Otherwise, your job will be to copy down the notes as they're going through the PowerPoint. So remember, this is a video, so if I'm going too fast, you can pause it at any time and you can continue writing and keeping up with me and then just play it as it's easiest for you. Okay, so don't worry if it feels like I'm going too fast. So the next part is I'm going to pop up this PowerPoint. So this is the notes you're going to copy. So if you notice, we already titled our page in our notebook, distance and displacement, speed and velocity. So you want to just continue writing and copying down these notes with me. Okay, so I'm going to talk through them. I realize you're going to be writing as I'm talking. So again, use the pause button to help you make sure that you're understanding this. All right, so distance and displacement, speed and velocity. You've probably heard both those words before, all 4 of those words. And I know a lot of people might think that they're very similar. They might even think that they're the exact same. And we do use them interchangeably in common language. The physics meanings of them are different though. So distance and displacement have different physics meanings. And same with speed and velocity, they have different physics meanings. But you will start to notice that as we start doing our problems later, that we will interchange speed and velocity a little bit more. So we might solve for velocity and, you might hear the word speed and velocity being used the same way. Because essentially they're very close in what we need to do for mathematic purposes. Okay, so distance. So go ahead and write down what we see here. So what is distance? Distance is the total amount of ground an object covers over the entire trip. Okay, so if I'm driving somewhere and I'm making lots of turns and going around curves and up and over mountain passes, the entire trip, that is my distance. So whatever ground I cover, okay? And it cannot be a negative value. So I can drive in a complete circle and come back to where I started. And I didn't, even though I changed direction at times, distance can't be negative. So we don't actually count it ever as a negative when we come back the other way. We just add it all together. So this is a nice little diagram that shows kind of the difference between distance and displacement. And we'll revisit again when we talk about displacement. But just for distance, if I start here and I drive along this dotted line around all these curves and end at B, that is the distance I've covered. So most cars now can tell you your distance because they record those in the odometer area. But if you knew, like I went this far and then I turned and went this direction and then I went this direction, you could add them all up and that's your total distance that you covered. Okay. And then I could also turn around and come back to A, and it wouldn't matter that I changed direction. I would just add that all up. Okay. And that's my distance. So we're going to do a quick little example. So I want you to write this down. The example says a car drives to Seattle that is 75 kilometers away. So car drives to Seattle, and I'm writing it on mine too. That is 75 kilometers away, and returns. So they're going to come back home. What is the total distance? So that is the question I'm answering, and I'm going to jump over to my camera in just a second. So my camera is right here, and I wrote it down. So let's think about this. We have a car driving to Seattle. It's 75 kilometers away, returns home. What is the total distance? So what I'm going to first do is I'm going to underline what I'm given. So we're going to learn these steps as we go. We're going to learn them a little deeper later, but as a habit, anytime they give me a number, I'm going to underline it. And it gave me a unit of kilometers, so I know that's a distance. And now they're asking for the total distance. So that's what is it that they're asking for. I always circle that. So I'm just going to get used to doing that as time goes on. Okay. So going back to the slideshow. So what would we do? We want to basically add it together. 75 kilometers plus 75 kilometers equals 150 kilometers. So if you looked at our diagram up here and pretend that this is A, you're starting here in Olympia and you're going to Seattle, you're going to go there, and that took you 75 kilometers, and then you're going to go back. Add them together, you get 150. So 75 kilometers plus 75 kilometers equals 150 kilometers total. So that's the total distance. Now note, that's not going to be the same as displacement, as you can see in the diagram. We'll talk about that in a second. So try another one. A car drives south to Portland, 150 kilometers, then east to Hood River, 95 kilometers. What is the total distance traveled? Okay, so I know that one might be a little bit more complex in the fact that we threw some directions in there. They changed direction. But does it matter when we're talking about distance? It does not. We just add them together. So 150 kilometers plus 95 kilometers, they drove a total of 245 kilometers, and that was their distance. Okay? So distance is pretty easy. You just add it all together. It doesn't matter how many turns they make. Doesn't matter if they came back. Just add it all together. Okay, so we're going to associate distance with speed. Speed goes along with distance. So when we're calculating speed, we use the distance that the object traveled. So what the definition of speed is it's the rate at which an object covers a distance. So remember, when we're talking rate, in this case, it has to involve a time. So we need to know that there is a time that it takes to cover a distance. And it cannot be negative because we're using distance, and distance can't be negative, so it doesn't matter if we change direction. Due to it not being negative, then speed also will not be negative, because time, no matter what, will never be negative. Time always keeps going forward, right? So when we use time in an equation, it's always positive. And since distance is positive, speed will always be positive. So the equation, write it down, is speed equals distance divided by time. So distance over time means distance divided by time. The units we use are distance is meters. So this is our standard unit, meters. Time is in seconds. That means speed's standard unit is going to be in a meters per second. So it's important to know that not only is this the standard unit, you might say, well, I've seen distance or speed in different units than meters per second, which is true. You might see kilometers per hour or miles per hour or even inches per minute. I mean, whatever distance and time unit you pick, that's what speed will be reported in. So we're going to do a little activity where you measure how fast the plates move. And they're going to be going in centimeters per year. So a distance of centimeters per year. So they move very slowly. Okay, so, but it's important to know our base unit that we always try to use for distance is meters, time is seconds, and speed is a meter per second, or a meter divided by a second. Okay, so let's try it. Example. So writing it down, what was the speed of the ball? So I'm writing it with you so I can solve it with you in a second. What was the speed of the ball that rolled 45 meters in 5 seconds? So we're going to do this the same way. So I'm going to jump up here and I'm going to walk you through how we do that. So again, remember what I told you. We want to underline what we're given. So we're given 5 seconds and we're given 45 meters. So we're given a distance and a time and we're looking for speed. So circle what you need. Okay. Now in the next round, when we really get into the math of this, I'm going to be even showing you that we write down our variables and all that stuff. So since we know that the equation is speed, so I'm going to use S for speed, equals distance divided by time, okay? I know that I need to find S, I need to have a number for D, and I need to have a number for T. So for all this to work, they all have to have a number. So that's the key though. We have 2 of them, we're going to find the third one. So we're going to have an S, a D, and a T. So these are our variables. Variables are what are the letters that represent what the things are that we're trying to find. So in this case, speed, distance, and time. Speed, distance, and time. And they're what make up the equation. Okay. So in this case, we have 2 things and we're looking for 1. So whatever it is that we're looking for, we're going to put an X. We're looking for speed. So the S right now is going to be X, and we're also going to put a unit that we're going to find it in. And we just talked about the units being meters per second. So we're looking for speed, which is X meters per second. We're given distance, which is 45 meters. So I'm going to plug that in there. We're given time, which is 5 seconds. And now we have all of the variables to solve using this equation. So I'm going to plug these in just like I see them in the equation. So X meters per second equals, that's my S. My distance is on top, 45 meters. My time is on bottom, divided by 5 seconds. Okay, now all I have to do is divide, and most of us have probably done 45 divided by 5 before, and we can do it in our heads, but if you have a calculator and need it, it's okay to use it. So 45 divided by 5 is going to be 9. Okay. Now, here's how the units work. We already know it's a meters per second, but let's look at it mathematically. We have an M or a meter on top, and we have a seconds on bottom. Now, we know in math, if something is on top and bottom and they're equal, we can cancel them. But since there is nothing equal, there's no meters on the bottom to cancel, and there's no seconds on the top, they have to stay. So that's why they stay in the units too. It's a meter per second because nothing cancels. So they both move over as the unit that we're finding speed in. So our answer here is 9 meters per second. Okay, so let's get back down there. And there it is, 9 meters per second. Okay, so there's speed. So we're going to move on to displacement. So displacement, while it sounds very similar to distance, it's actually an object's change in position from start to finish. So going back to that diagram that we were looking before, distance was this whole from A to B. And if we went back, it didn't matter. We just added all together. Displacement, we started at A and ended at B. It's that distance straight to it. Okay? It's how far you went from A to B. And I always like to say how the crow flies, because that's kind of a figure of speech people will use. Because a bird's not going to take all the turns. Birds are going to go straight because they can fly over everything, right? So they say the way the crow flies means what is the distance from point A to point B without taking any of the turns. So it's your change in position. You started here, ended here. What was that change? Now, if I went back, we'd actually have ended where we started. So our change in position, our displacement would have been 0 if we returned back to A. Because we started at A and ended at A, we didn't displace ourselves at all. Even though we went a distance, we didn't displace. So that's the big difference between the two. It can be negative or positive. So now direction does matter. So that's why we got to 0. If we went, let's pretend this number here was 20. If I went 20 kilometers to B and returned back, now I went negative 20. 20 positive plus 20 negative is 0. So that's how I got back there. So if I stopped in the middle somewhere, let's say I went 20 kilometers this way and then came back 10 kilometers and stopped in the middle, I went positive 20 plus negative 10, so my displacement would have only been positive 10. So that's the idea about displacement. It does have a negative and positive value, and we'll practice that more. So yeah, direction matters. So direction of the object matters. So it depends on if I go forward or backward. Okay, so the example. A person walks 3 kilometers south and 4 kilometers east. So now we're talking direction. What is the displacement? Okay, so I'm going to write that down. So this is example 1. A person walks 3 kilometers south and 4 kilometers east. What is the displacement? Okay, so in this case, it's a little different because we changed complete directions and we want to know from point A to point B. So I like to draw it out. If you were to draw it, you would notice that it would look something like this right triangle. A would be the 3 kilometers south. So as we go down from where, let's say we start here, we went 3 kilometers south, and then we turned and went 4 kilometers to the east. Now we could add A plus B and get our distance. 3 plus 4 would have been 7 kilometers. That's the distance, but we don't want distance, we want displacement. We actually want C here. So we started here and ended here. We need to know the distance or the change in position, which is the displacement. So notice we get to use this lovely Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to walk through that one with you on the camera again. So a person walks 3 kilometers south. So again, I have a number. So I'm always going to, and I like to, if there's a direction, I like to add that in. And 4 kilometers east. What is the displacement? So just like the picture, they went 3 kilometers south, 4 kilometers east. Oops. And we want to know this displacement here. This between point A and point B. So this is the start and this is the finish. So on these, it really helps to draw it out. So we know that a squared plus b squared equals c squared. We're going to call this A, we're going to call this B, and this is C. So I'm going to plug it into our a squared plus b squared equals c squared equation. So A is 3 kilometers. So it's 3 kilometers squared, and I'm going to put the squared outside the parentheses. And notice I still put in my unit. Units always matter. I'm going to add that to b squared. So 4 kilometers, and I'm going to put parentheses around it and square it. So by putting the parentheses, that tells me I have to square everything inside of it, including the unit, and equals c squared. We don't know c yet. We want to find c. We don't want to leave the squared on there. We want to find c all by itself. So the next step would be doing squaring everything. So remember, you always do your exponents before you do any addition, the PEMDAS. So you square first before you add. So we're going to square 3. And if you remember how to square, squaring is any number times itself. So if you know that 3 times 3 is 9, you're good to go. If you needed to use a calculator, if you have a phone calculator, you could do 3. And then you look for the little button that says x2. That's squared. There it was, 9. So if you don't have the little x squared button, or maybe you don't have a phone calculator that's got the scientific stuff, you could just do 3 times 3 in your calculator if you forgot that it was 9. And I did 3 times 3 is 9. So we know that's 9, but notice I still have my units here. My units are also squared. So don't let this throw you off. Okay, so now I have 9 kilometers squared, plus I got to do the same thing with 4. So I know that 4 times 4 is 16, but again, if you need to use your calculator, that's fine. So 16 kilometers squared. So don't worry, don't let that worry you, because we'll get rid of that squared soon, because we're going to have to get rid of the squared and the c. Equals c squared. So notice I just dropped it down. We didn't do anything with c yet. So now I'm going to do my addition. So I've done my exponents. Now I'm going to do my addition. So 9 plus 16 is going to be 25. So 9 plus 16 is going to be 25. Now, since these are like units, right, kilometers squared and kilometers squared, I can add them. You can always add like units. Okay, so kilometers squared. So I'm still with this squared here, equals c squared. All right, so I'm not done though. Remember, because I don't want c squared, I want c. So anytime you want to get rid of something in an equation, you do the opposite equation. You do the opposite type of skill. So in this case, c, when you square something, what's the opposite of squaring? The opposite of squaring is taking the square root. So to get rid of the squared, I'm going to take the square root of c, which means the squared will be gone and I'll just have c by itself. But according to math, what I do to one side of the equation, I have to do to the other side of the equal sign. So I have to also square root 25 kilometers squared. So hey, that's going to help us get rid of that squared there. Now, some of you might already know what times what equals 25. But if for some reason you struggle on that, again, 25. Now, you will need to have a scientific calculator to do the square roots if you don't know how to do them in your head. But on my calculator, it's this little button here that says square root x inside, and there's a 2 on the outside. That's square root. When I click that, it gives me the answer of 5. And I can do my reverse math. I know that 5 times 5 is 25. So I've got 5. Now I also square rooted the kilometers squared. So that got rid of the squared and just leaves kilometers. So my answer for displacement was 5 kilometers. So essentially I found the hypotenuse of the triangle here, of this right triangle, because remember, right triangles. So this is 5 kilometers, C. So my total distance is 7 kilometers, 3 plus 4, but the displacement from start to finish is 5 kilometers. Okay, so moving on. I got to get back to where we were. Okay, so velocity, write this down. So velocity is basically the speed something goes, but direction matters. It matters if it's going north, south, east, forward, backward, okay? Speed in a direction. It can be positive or negative value based on the direction of travel. So because, like displacement, direction matters, if I come back or I'm going backwards, my velocity can be positive or negative. Okay. So in the equation, we use the displacement value or the change in position of an object. So I want you to know right now, I'm going to give you this equation, velocity equals displacement divided by time. But as time goes on, we'll end up using distance quite often as our displacement value, because we might just measure the distance it moved in one direction to get a velocity. So even though displacement is a little different, in a lot of our labs, we're going to be using the distance an object traveled to find velocity, because essentially, if it doesn't come back or change direction, it's still going to be the distance it traveled. So write this down for now, velocity equals displacement over time. But again, you'll see us interchange distance and displacement occasionally when we're doing math problems. All right, units are the same as speed. So displacement is meters, time is seconds, velocity is meters per second. So let's do an example. A skateboard rolls forward 24 meters in 6 seconds. So this is an example where I only gave you one distance of 24 meters because it was forward. It didn't come back. It didn't change direction. So it rolls 24 meters in 6 seconds. So write it down so we can solve. And what is the velocity of the skateboard? So they're asking for velocity. So this is going to be solved exactly like our speed one, because we are actually not changing direction. So I'm going to go over the camera and remember, same thing. I'm given 24 meters in 6 seconds. What is the velocity? We know that velocity equals displacement divided by time. So the displacement it moved since it went one direction was 24 meters. Time was 6 seconds. Velocity is what we're looking for. We're looking for a v, d, and a t. So these are our three variables that we're looking for, v, d, and t. So we know since we're looking for velocity, it's going to be x. The units, it's a meter in a second, so it's going to be x meters per second. The distance is 24 meters, and the time is 6 seconds. And now I just plug it in. X meters per second equals my d, my displacement, or distance in this case, because it was just one direction, 24 meters divided by time, 6 seconds. So most of us can do that in our head. 24 divided by 6 is 4. Since I can't cancel meters or seconds, it stays. I get 4 meters per second. And that is my velocity the skateboard is moving. Okay, and that is the end of the PowerPoint. So our next lesson will be actual practicing more problems with the math part of it. Okay, see you next time.